Hi everyone, welcome to my video. Today we'll be talking about time. How important it is to have the correct time and date in our servers, our workstations, and all the electronics that connects to the internet. We have plenty of machines that rely on a correct time and date, and I'll be showing you how to use NTPd on Linux Ubuntu to set time and date from local NTP servers and check if they are in fact correcting time in our server and our clients. I will demonstrate also how to change manually the NTP server in a Mac OS operating system. Okay? Before we start, let me remind you, you can subscribe to my channel and press the bell button to get notifications about all the videos I'll be publishing. Now, let's do it. Okay, first thing we need to do in our server is to check the status of our systemd-timesyncd. This is a default daemon for time in Ubuntu distribution, and to start installing NTP and use it, we need to first disable and stop this daemon so they do not enter in conflict with each other. To do that, we'll be using systemctl. As you can see, I am synchronizing time at this moment with this daemon, but I want to change to NTP. Let's change here to stop. Be careful because it will be only stopping for now. After a reboot, it will be activated again. So we need also to disable the service. Now let's install NTP from Ubuntu Repository. This is a very small software we are downloading and installing. We have a very big worldwide NTP network with lots of servers, but with different status in the network. It is called Stratum, and we will be using servers from Stratum 1 and Stratum 2. But now let's configure the firewall. I'm showing you the status. I will enter here a command to get a new rule running in our firewall. It will be port 123 in UDP protocol, the standard for NTP. So now let's enter the /etc folder and open ntp.conf in our nano text editor. Let me scroll down so we can get here to line 21. I will be disabling these lines because I want to use different NTP servers in my configuration. Of course, Ubuntu Pool is a nice one because it will give you the best NTP servers in your local area, your region. But for our experiment, I want to show you new servers that we have available near Lisbon in Portugal. So typically, NTP servers are from universities, public institutes, military, or from the ISP companies. Your internet provider should have an NTP server available for its customers. I'll be using ntp1.tecnico.ulisboa.pt. This is an engineering college in Lisbon, and also ora.roa.es. Now let's restart the service. and check its status to make sure that the configuration we have just made is okay. We have still a time error over there because we are not synchronized. Let's just test with a ping that we in fact have a route to both servers. The first one is okay, the second one also. So we should have no problem synchronizing. Check the latency. 11 milliseconds and 138 milliseconds. Very different because one is in Lisbon, the other one is in Spain, in Cádiz. Very, very far away. Okay, so let's wait a little bit. I'll repeat the command to check if we already have synchronized our. Not yet. And now we have. So I will be talking about that. First, let me put some network traffic showing here in a second window. This is a remote connection to my server through SSH protocol. I'll be activating verbose mode. The -n in this command stands for numbering, so we see the IP addresses instead of the host names, and the correct network interface filtering for port 123. So this is what we need to check the traffic and see that every time my server asks for time date through NTP, we will see the traffic. And here we have it. Traffic has been changed between our local daemon and the remote servers that give us the information. We are using Structum 2 and Structum 1. The Spanish server has an internal GPS receiver and the college in Lisbon has a Structum 2, so it relies on a Structum 1 server. Let me have some more servers here. The second one from Lisbon Engineering College, and I will also have, opening here some space, a new one from an astronomy observatory also in Lisbon, so we can have more servers configured here in our local daemon. Let's save and exit and check if everything is okay. Restarting to see if we already have these new servers in our configuration. Okay, as you can see, we already have 4 servers and we have just restarted, so we are not synchronized yet because we are completing the process but starting over. You see some traffic here being changed between our local IP address and public IP addresses from these servers. All the time information is here in the packet. This is open traffic, okay? It's not encrypted, so you can see everything happening from TCP dump. I will add a new one, the last one, and after I had the last one, I will restart again and check if I have 5 servers. Here we have it. I'm fast forwarding time so we can complete the cycle and check traffic again, where we see that they are pulling servers again. Now you can see in the Structum column we have 4 Structum 2 servers and 1 Structum 1 server. Let me now show you how to configure a client in Mac OS, I am setting manually the NTP server I want my Mac OS to use to synchronize time date. This is a manual command. I will put my local IP address of my Ubuntu server and it is confirmed. So if I check the correct network interface, I will see the traffic it will generate while it communicates with Ubuntu server to synchronize time date. Some more comments just to check that everything is okay, and I have switched on NTP synchronization, and as you can see my Mac OS is changing packets with Ubuntu server to synchronize its time and date. Okay, here you can see graphically the IP address and time being synchronized. You see the asterisk, that is the server we are using, and the plus means that these servers are candidates to be chosen if something goes wrong with the best one. In fact, we are using the Spanish server, but it has the biggest latency. What it has that is very good is the offset is very low and the jitter is also low. So it is calculated and chosen the best server each time the cycle completes. So this is a dynamic process we have in our local daemon running, because it has to keep choosing the best server every time new packets arrive. Now let me open a big clock. This is a funny thing, so we can check time. Let's put it big to give the correct idea of how important it is to have correct time and date in our machines. We have databases, we have daemons, we have point of sales, we have workstations, we have smart watches, we have lots of different equipments that rely on correct time and date, all the electronic commerce and everything that runs on the internet. In your local network, don't forget to configure your NTP server and configure also your workstations to synchronize time from the very same NTP server, so you can maximize precision and performance. Okay guys? So don't forget to subscribe to my channel and press the bell button to get notifications about all the videos I'll be publishing. That's all for now. Thank you. Hope to see you on my next video. Bye bye.